Hello everyone, my name is Dustin Vance and this is my General Chemistry 2 Advanced Concepts Presentation 7 for magnetism and homemade ferrofluid. So first things first, I'm going to share a couple videos of what happened with my experiment. I did have some issues with it. I'll discuss those at the end, but I wanted to provide proof that I at least tried and kind of show what happened. So in this first one, I've taken the printer ink, I've mixed it with the vegetable oil. I kept mixing it to get it thinner and thinner. I got the strongest magnet I had within the household. It's one of those egg-shaped magnets that are typically a children's toy, but it seems strong enough, or what I would think it would be strong enough for this experiment, and it doesn't really seem to produce results for me. You can see I'm trying to do it, and it kind of shifts a little bit. I was wondering if perhaps this was a result of the magnet, or maybe I had nudged the plate. I wasn't quite sure. So I tried it multiple times, wasn't really sure. So I decided to take it just into the fluid, and as you can see, I'm not getting any sort of magnetic results here. There doesn't seem to be anything attracted to the magnet, and I think a large part of that problem is in the quality of the ink, or what is in the ink, and I will discuss that later. And just to be sure, I took the magnet, stuck it against the refrigerator several times, moved it around. It's plenty strong enough to hold its place onto the refrigerator. It seems decently strong enough. With it getting near its opposite, the same shaped magnet, they can pull each other together from a couple inches away. It seems of adequate strength to me for this experiment, so I'm unsure of why that part did not work. So now it's important to discuss what was supposed to happen. Although I did not see results, I can still understand what was supposed to occur. So the idea was to make a homemade ferrofluid, which is a magnetic fluid that attracts to the magnet through its magnetic field. And the way that it does this is it's not so much the electron pairing, but it's the way the electrons are presented within the metal, because there are several metals that are not magnetic. What makes certain metals or certain materials magnetic is the fact that the inner structure forms a pole, and that pole needs to be able to attract to the opposite pole of the magnet. That's why I was rotating the magnet around. I couldn't tell which pole was which side, or if it was the top, the bottom, the tips, or anything like that, so I was trying all of it. And if there is a pole within the material, then it attracts to the opposite pole of the magnet from the magnetic field. So that is what I was trying to get to occur, but it did not happen. And of course, we need to discuss what would be magnetic within that ferrofluid, and that would be nanometer magnetic materials, because it's not the vegetable oil, of course. So what the vegetable oil is doing is it helps reduce resistance between the magnetic materials, and it allows them to flow more freely and not clump together. That's what it allows it to form spikes in different shapes in that video, because it is able to move freely and adapt to whatever the field shape is. As I just mentioned, the magnetic field is what makes the fluid form those different shapes, because you can't see the magnetic field, but it is a force. So when those opposite poles of that material found in the ferrofluid come into contact with the magnet, they start to bind together and join through that magnetic field, and they form the shape of that opposite pole. And that seems to be spikes in this case. That's why at first I was hoping that maybe the fluid moving was those poles trying to attract the fluid moving towards the magnet, but in my personal case, I do not think that is accurate. And as mentioned, the vegetable oil, helps reduce the clumping of the material, and it just lets it form to whatever shape the magnetic field, wants it to naturally develop in. You can get similar results for this. Let's say if you take a strong magnet and put it over sand, oftentimes there are tiny iron deposits in the sand, and you'll pull the iron out of the sand onto the magnet, and it too will form those sort of spike-like shapes, although in a much rougher pattern, because at that point they are clumping together and forming a more solid mass than they would within the fluid. So why did my experiment fail? My primary theory for why the experiment failed was I think the ink did not contain any magnetic material within it. I was only able to find one type of ink that's within a bottle at my local grocery store. That's the only store we have in the area. And it is printer ink, so I was optimistic, but it still did not appear to have the right composition for this lab. I tried to find the inkjet printer ink that was referenced in the video for the lab, but the only thing that was there was very tiny cartridges, and they were rather expensive, whereas that bottle was $10. There is also the possibility that the magnet was not strong enough. I do have concerns for that, but my primary theory is the fact that the ink did not have any magnetic material in it whatsoever, because as I showed in the video, the magnetic power of the specific magnet that I had was strong enough to attach to a refrigerator and withstand me pushing it, rolling around, twisting it, spinning it. Nothing made it fall from the refrigerator. So I do think the primary issue was the ink that I had. Thank you for taking your time and watching this presentation. I do apologize that the experiment failed, but I hope my explanation on what should have occurred was adequate and that it showed my comprehension of the topic. Thank you.